Assalamualaikum and good day everyone. I'm Bagus Aji Supeno and this is machine learning-based network anomaly detection analysis on MODBUS protocol of industrial control system against DOS attack. On this project, the ensemble learning and deep learning will be examined to do anomaly detection for DOS attack identification on ICS network dataset, including binary and multi-class classification. This project employed the WUSDL IIoT 2021 dataset, which is well-labeled dataset, and the proposed model would be DNN and ADABUS with logistic regression. Let's go to the Google Colab. We start to import the library and load the dataset from the Google Drive. The dataset exploration to describe the overall dataset and see the correlation matrix. For cleaning the dataset, that is including drop the space or tab before columns name and null values checking and duplicate rows elimination. In binary classification, the label will be transformed into 0 and 1 by manual, and then splitting the dataset into 75 for training and 25 for validation and testing. Training data will be rebalanced using random undersampling, and the last step is feature elimination based on extra tree classifier. The composition of the model is include the baseline model, search hyperparameter process, and then the proposed tune model. All the metrics for classification tasks is employed from accuracy, precision, recall, F1 score, and then the confusion matrix. In multi-class classification, the label will be retransformed using label encoders to become numeric values from 0 to 4. Splitting the dataset just like before and rebalance the training data using smooth and random undersampling algorithm. The composition of the model on this part just remain the same as binary classification before. Move on to the result and analysis. Baseline for DNN would be 2 layers NN, and the proposed DNN will be tuned by tuner-keras algorithm with total 10 trials. Monitoring of training and validation over the matrix, and scenario 3 is outperform the others with lowest validation loss. On the testing data, the accuracy from baseline to proposed model is from 98% to about 99% with significant improvement on precision. On the confusion matrix, showing low false positive and false negative indicates the better generalization on the proposed model. Same parameter is also used for multi-class classification. In testing data, precision and recall become a significant improvement from the baseline. High true positive is achieved and dominated by normal class as the majority of classes. Move on to the second model. The baseline of the ensemble learning will be logistic regression and will boosted by ADABUS algorithm. Grid search with 3-fold cross-validation is employed with total 25 combination and 75 of fittings. The monitoring of training and validation is done by learning curve over accuracy and loss. The result shows significant improvement on recall and F1 score is achieved by scenario 1, indicates better at classifying positive instance. Significant decrease on false negative, while increase on false positive is reached by this model. Whereas for the multi-class classification, can be said that only a slight improvement of the overall performance for these tasks from the baseline. In summary, the DNN algorithm is outperformed the ADABUS for both of tasks, with all metrics showing about 99%. The strength of the NN model consists feature learner no need additional feature elimination and can achieve a high score, whereas the ANOMALY can improve the scores from estimator and computational efficient. Instead of his strength, the NN is computational expensive and less interpretable, while the ANOMALY is depend on estimator and need a robust pre-processing stage. The trade-off is more complex model will more accurate, but hard to interpret. The imbalance issues effect on the variance in the classes. The lesson learned is with the monitoring of the learning process, we can reach a sufficient score based on the model, and the model selection is influence the successful of the project. For model improvement is considered more complex model, solving potential bias and Bayesian optimization for ensemble learning. Reflecting the project in solving imbalance issue is challenging, and the experience in build a machine learning model. In conclusion, this project is success to do tasks but have to take a look at the potential bias result, boosting algorithm showing adaptability while DNN shows scalability. Many things to do and learn, with a wonderful experience for a successful machine learning project development. That's all from me and thank you very much.